start with a little trip down memory lane. I'm going to review 1,758 divided by 3 on the left. Pull that up. I think I can. Okay. So most of you, I'm guessing, were taught long division where you put 1,758 inside the division box. Did it look like this? And then you put 3 on the outside, divisor. So this is called your dividend, the thing you're dividing. And the divisor is the thing you're dividing by. Okay, what sorts of things do you have to ask yourself when you want to start dividing 1,758 divided by 3? Okay, so Jack jumped right to, how many times does 3 go into 17? Technically, what did you ask yourself before that? How many times could 3 go into 1? But it can't. It's too big, right? So then you got to go over to the next one. So how many times does 3 go into 17? 5 times. So because we're working with 17, we put 5 right above that, right? That's in the hundredths place of 1,758. So we put it in the hundredths place in the quotient, in the answer. And then what do we do with that 5? First, you multiply it by 3. So 5 times 3 is 15. And then subtract this thing, right? And 17 minus 15 is 2.
Drop the 5.
Drop the 5. And now what do you do?
Drop the 8.
Okay, you could drop the 8 if you wanted to, or you can just drop the 5. Some of you probably just drop the 5 and you drop the 8 later. But then you re-ask yourself the same question, right? How many times does 3 go into 25? Okay. Now remember that when you subtract right there, it shouldn't be more than 3. Otherwise, that meant you could get 3 in it one more time. Okay. So how many times does 3 go into 25? 8. 8 times 3 is 24. And what are you doing with that? Subtracting it. And then you come up with 1 and you drop your 8. And then you ask yourself,
how many times is 3 going to 18?
How many times is 3 going to 18?
6.
6. Which leaves me with 0 remainder. Okay. Cool. Now what if you had a remainder of 1? What would you do with your remainder 1? Oh, don't you remember those good old days? R1. What else could you do with the remainder of 1? Okay, you could do a decimal, and we're not going to do the decimal root, but you could put a 0.0 and then keep going and try to figure out if it repeats or it keeps going or if it ends. What else could you do with the remainder of 1? R1, decimal, fraction. So we're going to be thinking about the fraction part of it. So if you had a remainder of 1, what would your fraction be on the back? 1 over 3, your divisor, right? Okay, so those things are going to be the same. We're going to do it with x squared plus 7x minus 2. So, what goes in underneath?
X minus 2. No, x squared plus 7x minus 2.
The dividend goes underneath. X squared plus 7x minus 2. What goes on the outside of the division box? X minus 2. Okay. Now, there's a slight change here because it's not numbers anymore, right? So I can't ask myself how many times does 3 go into 1 or how many times does 3 go into 17. And there's a lot of terms in both polynomials. So the best thing I can say is don't worry about all the terms. Only worry about the first term. So x squared divided by x is x. Or how many times does x go into x squared? X times. Well, it's better to do x squared divided by x. Okay. So then, x squared divided by x. It's just like this. 17 divided by 3 was 5 something, right? Okay. So, x squared divided by x is x. What do you do with that x on top? Multiply it, and you're multiplying it by what? x minus 2. So I'm going to put that over here on the side. X times x minus 2 is going to be x squared minus 2x. Well, you're multiplying x by x minus 2. So you got to distribute it. You're multiplying it by the whole thing, aren't you? Where did the 7 go?
It's right there.
It's just in the problem. It hasn't gone anywhere. Well, I set up my problem, right? That's like my 1,758. Do you agree with that, Rihanna? It's like my dividend. And then, like, when you're doing this, we thought about 1, but 1 divided by 3 doesn't work. So then we thought about 17. 17 divided by 3 was 5. And so then we did 5 times 3 was 15. And that's where I'm at. I just put the x right there. And I just did x times x minus 2. Yes, Luke?
Why didn't you put the x over the x squared?
Oh, so the same reason I don't put the 5 in front of the 1. Because at the moment that I'm dividing 3 by 17, that's in the hundreds place. So in the polynomial, this column should only have x's in it. This column should only have x squareds. So when I choose x, it should go above the x's. It's like in its right place. That's a great question. Thank you. Okay, now normally, what would I do with this dividend, x squared plus 7x minus 2, and the thing that's underneath? Subtract. Now here's where you have to be a real honors algebra 2 student. You want to subtract all of it. So if there's 2 terms, you got to subtract
All of it.
both of them. Okay, so I'm going to put in negative, but I'm going to put it in parentheses. Okay, this is where most of my students are going to make their mistake. Okay, that's why I'm being really careful about this right
So
now.
you just always
I want to subtract all of x squared minus 2x, so that means it's really going to be minus x squared and plus 2x. So I'm going to go ahead and change it to addition at that point. So it's plus, negative, positive. Well, what happens with x squared minus x squared? It cancels out. If that doesn't cancel out your first terms, you chose wrong or you multiplied wrong. Okay, so go back. It should cancel that out. What about 7x plus 2x? 9x. And then what would you do? Drop the negative 2. And that's like this point right here when we dropped the 5, so we had 25. You just restart, right? Now, 25 divided by 3 was 8. And that's how we got, well, we thought more like how many times does 3 go into 25? But so we just restart the process. 9x divided by x is 9. So that's the number I need so that the first terms will cancel, right? Is a 9. And then what would I do with this 9? Multiply it by x minus 2, but I got to multiply it by all of x minus 2, so I'm going to write it off to the side. You may not write this off to the side as you get better. Okay, might leave that part out. And that gives me 9x minus 18. Now, what am I really doing with those 2 lines? Subtracting that whole part.
But you're making it new.
So I'm going to change the sign of both numbers, right? So I'm going to make this plus a negative and a positive. And 9x plus negative 9x cancels. If that doesn't cancel, something went wrong. You want to go back. It should cancel the first term. That's the whole goal right here. And then negative 2 plus 18?
16.
16. That's our remainder, right? Like we're at the end of the division, right? It's like back here when we got to the ones, we were at the end of that value. Okay, I didn't realize it divided nicely. I should have tested that. But it comes out nice. So we're at the end right there. So we could say like R16, but we're above that. So this is going to be our answer. X plus 9 plus 16 over X minus 2.
So this entire time we don't even use the -2.
I'm sorry, what?
The x minus 2 for the outside part, we don't divide by that at all.
We did divide by X minus 2. That's what we were doing the whole time.
We're doing by x.
You can only think about, like, that was the whole thing at the beginning, right? Like, there's a lot of terms right there, but you can't worry about all of them. Like, we can't worry about 17,058 if we don't know what that is. So we break it into smaller chunks. What is 1 divided by 3? What is 17 divided by 3? And work from there. So the idea of that is, like, you can only really worry about the first term when you choose the thing at the top. But I was actually dividing by X minus 2 because then what did I do with that X? I multiplied it by the whole thing. So it's not that I'm not dividing by X minus 2. It's just I can't worry about all the numbers all the time. Because then I can't do the problem because I can't see ahead. So I can only worry about the first numbers. Your goal, Rihanna, is to get these first ones to cancel. It's okay if the other ones don't. They probably won't always. Okay? But your goal is to get the first ones to cancel. That's how you divide. Okay, questions, concerns? Okay, what that means is, if I did my answer or my quotient, x plus 9 plus 16 over x minus 2, and I multiplied it by the thing I divide by, x minus 2, I should get x squared, what was it?
Plus 7x.
I should get x squared plus 7x minus 2. That's the idea up here, right? That 3 times 586 is in fact 1,758. Now, this would be actually like a pretty easy check for us. If I distributed x minus 2, that'd be x times x minus 2. That'd be 9 times x minus 2. And what would happen when I multiplied 16 over x minus 2 by x minus 2? It'll cancel, and I'll just get plus 16. That's x squared minus 2x plus 9x minus 18 plus 16. That's x squared plus 7x minus 2. Worked. Okay. So the ideas, the concepts of division have not changed, right? Your 4th grade self understands this process. There's a few things you have to be really careful of, like remembering to subtract all the terms in that second line and not just the first term. Okay. All right, let's do one more. X cubed minus 8x plus 3 divided by x plus 3. Now, there's one thing to be really careful of, and this happens whether you're doing long division or synthetic division with polynomials. When you look at that cubic function, x cubed minus 8x plus 3, what is missing? My x squared. So, it is my job to just leave a placeholder for x squared. Because remember Luke's question about why I put the x squared, put the x in the quotient? And I said all the x's have to be in this column. If you need a place for x squared, you've got to put that placeholder right there. Okay, so when I drop this into my division box, I'm going to put x cubed at the front. but I'm going to make sure, in case I have any x squared terms through multiplication or through division, that I have a place to put it. So I'm going to put plus how many x squared? 0 x squared minus 8x plus 3. If you don't see any, you had 0. So make a little note in the margins of your papers if you need to. Put a 0 for any missing terms. Okay, if you're going to forget about the 0, you write yourself a little note. Put a 0 for missing terms. And we're going to divide by x plus 3. Okay, now remember, when you start, you can't worry about everything. So you only worry about the first terms.
Which is x.
In this one, yes. X cubed divided by x.
Ooh, x squared.
X squared. Oh, do you see I needed that x squared? Almost always you're going to need the missing spot. So you just better put the missing spot in. You won't get the right answer if you don't. Otherwise, you'll think you'll hit the end of division and you haven't.
So do you just minus the exponent from it when you divide the?
I mean, yeah, that's what division is. Subtracting exponents. That's a property from algebra 1. Let's see. Multiply x squared times x. X cubed. X squared times 3. 3x squared. Do you see I didn't write it off to the side? I just distributed it. Are you okay with that? If you need to, you write x squared times x plus 3 right over there. So you know where it came from. What are you doing with those two things? Subtracting them. And you're subtracting both of them. So I'm going to go like this. Change signs, change signs. You see how I'm shortcutting my work now? Okay, I just distributed my negative right away. Change the sign of every term. Then my x cubes cancel, which is what I wanted them to do. 0x squared minus 3x squared. Negative 3x squared. And I'm going to bring down my next term. Minus 8x. If you want to drop down the plus 3, that's fine. Okay, now what do we think about? First terms only. Negative 3x squared divided by x. Negative 3x, so that belongs in the x column, right? Negative 3x. Multiply it by your divisor, which means you have to multiply it by both terms. Negative 3x times x. Negative 3x squared. Negative 3x times 3. Negative 9x. What do I do with those two lines? Subtract them. So I'm really switching the signs of the green numbers. Since they're both negative, they're going to turn into positives when I subtract them. And that leaves me with x plus 3. Oh. What's going to be my last number? A plus 1. And then 1 times x plus 3 is just x plus 3. And when I subtract that, I subtract the thing from itself, so it's 0, right? That's going to be negative and negative. I'm going to go ahead and put a little smiley there. I like that. That makes me feel good. So my answer, or my quotient, is x squared minus 3x plus 1. Cool.
Good job, team.
Okay, so division with polynomials can be done with the same methods that you learned back in 4th grade. Long division. You're going to need to practice this, or you're going to make some of those common mistakes like sign errors that I don't want you to make. And it's going to affect you later on because we'll use it for other things. Now we're going to talk about synthetic division.
That wasn't synthetic division?
Nope, that's long division. Have you seen this problem before? Yes, it's our first problem. So I've got your work off to the other side. And we just want to be looking at it compared to like synthetic, where you see some of the numbers in synthetic, how they show up in long division. Okay, so I like to think about synthetic, like anything that is synthetic in the real world is like man-made, yeah, fake, not the real thing. And so this is like a quick version of long division, but it's like you're not doing all the steps to thinking about long division like you would in 4th grade. So, synthetic division generally takes up 3 lines of paper. I do write above my box, so sometimes if you want a line for everything, it would be 4 lines of paper. So this should be 2 lines. Like you have a line, and I'm going to write above it. It looks like a big L. That's your synthetic box.
Big ol'.
Okay. Inside the synthetic box will be the coefficients to your dividend. So with synthetic, we don't use any x's. So what is the highest exponent in this polynomial?
2.
X squared. So I have to have a column for x squareds, x's, and numbers. And again, I'm only going to put in their coefficients. So that's the number in front of the term. So for x squared, I would put in a 1, 7, -2. Okay. Now, on the outside of synthetic, you're going to use the 0 of the linear factor. So if your linear factor that you're dividing by is x minus 2, its 0 is what x value makes it equal to 0. So if you set x minus 2 equal to 0, then x equals
2.
2. So x minus 2 equals 0, so x equals 2. So outside of my synthetic box is 2. If I'm dividing by x minus 2, it looks like a positive 2 on the outside. Okay? Okay, now, there are 2 steps. It's my little mantra, I call it. I just keep saying it. Add down and multiply.
What?
Add down. 1 plus nothing is 1. Multiply. 1 times 2 is
2.
2. Okay, so you're adding the 2 lines in the synthetic box. If there's nothing there, which there never will be for the leading coefficient, it's just the leading coefficient. And then you multiply by the thing that you're dividing by. 1 times 2 is 2. Add down.
9.
Multiply. 9 times 2 is 18. Add down.
16.
Whoa.
No.
Whoa.
Why did you do that?
Whoa.
You see those numbers?
Yeah, I do.
They're showing up in your regular division? Okay, so the thing about synthetic is these numbers at the top were x squared, x and a number. We divided by an x, so everything drops 1 exponent. So this is now x, your constant, and your remainder. So when you write your final answer, it will be 1x plus 9 plus 16 over the thing I divided by, x minus 2. Same answer. You could use it, but eventually you're going to want to switch over because you don't have time for long division. Okay. Let's try it with that second example. You're going to grow to love synthetic. I know that at first you're like, I like thinking about it. But
Sorry.
synthetic, we're going to want to be able to do this really fast.
How did you figure out that it was x, the number and the fraction?
And the remainder?
Yeah, the remainder.
Because if you take a quadratic, which was what it was, x squared,
Yeah.
and we divided by a linear factor, x minus 2, then everything is being divided by an x, so it reduces 1
Oh,
exponent.
okay. So x would then just go to the coefficient and then other ones.
Okay, so now we're going to set up our synthetic box. What's our highest exponent? x third. So what else do I need?
X.
X squared, x, and a number. Never can you ever leave anybody out. So when we drop in the coefficients, we're going to have 1, 0, -8, 3. You have to have a placeholder for the 0. That's a step in division. What number goes outside the synthetic box? -3. What is your mantra?
Add down and multiply.
Add down, multiply. Write that down if you need to. Add down, multiply. Add down, multiply. You do it until you get to the very last add down. Then you're done.
Where did you get the -3 from?
X plus 3 equals 0.
Oh,
X equals -3. Okay, so when I add down, what do I get?
One.
1. It's always going to be the leading coefficient.
Yeah.
Don't overthink that, okay? There's nothing to add. It's 1. 1 times -3.
Negative. Negative.
0 plus -3? -3. Then
9.
multiply. -3 times -3? 9. Then 1. Add down. Then
Times -3 with just 3 add down.
times -3. Then
Add down.
0.
we're going to love the zeros later. So I'm going to just make you really happy. That makes me so happy. Okay? So these were x cubed, x squared, x and a number. So down here it's going to be 1 less. X squared, x, a number, and what's the last one? Your remainder. So we would have x squared minus 3x plus 1. And that's what we got in long division.
Let's go. That's way easier.
You already know what.
Does it work for regular numbers?
No. The last one was 3. It will depend on how many terms you start with. So if you had like an x to the 6th polynomial, then you'll have like 7 terms across. Okay. All right. Any other questions or clarifications that you would like me to make? Okay, I've got 2 I want you to try. Now, before you get started on these 2, which division method could you use for the first one? Look at your divisor. You could use either. You could do long division or you could do synthetic because you have a linear factor. So I'm going to tell you to do which one? Synthetic. It should be fast. Okay. Which method would you have to use for the second one? Long division. We don't know how to divide synthetically with a quadratic factor.
Only
So we don't have that option, so we would do long division. Okay? Work, please. If you have a question, let me know. If you want to check with your table buddies, check with your table buddies. What's your setup look like?
I think you have
Which one are we doing?
I think you should probably have a 0 in there. Just because the whole like the
Very good. I love what you're talking about.
Minus 3x not so it's going to come down first. So we just had a reference.
Beautiful. Forward through.
Really? Okay. -1.
It's good for you to check, but yeah, like.
Oh my, this number's so big.
Can't even think with you two.
Oh, I messed up.
Oh yeah, you add. Oh wait, no, that's right.
I messed up.
You forgot what?
The placeholder.
Don't you ever forget the placeholder. That's why I start by writing like the highest exponent at the top, x to fifth, and then I just label all the way down. That way it double checks it for me. Did you get your placeholder? Yeah, there are some big numbers on this one. There are some big numbers. Do not be afraid.
So I'm not doing this one?
I mean, questionable, but there are some big numbers. Mason, are you done with this problem?
I had to restart because I didn't have my placeholder.
Then you better be more focused.
We're getting there. But yeah. Yeah.
Ooh, how is this even possible?
Okay, I'm going to start my adding down and multiplying. So add down to get -1. Multiply, I've got -5. Then I'm at -8, which gets me to -40. 0 plus -40 is -40. Times 5 is -200. So then I'm at -198. Times 5 is -990. Am I right? -990. Oops. Only no one knows what was going on in my brain right there. -990. That's -5 plus -990, so -995. And that's 4,975, right?
Oh, yes.
So that's a -4,975, and that's with the 10. And then I will get negative 4,965.
Never get through.
Oh, I'm glad I'm not doing long division right there. So then my answer, remember this is x to the 5th, now my answer is x to the 4th. X to the 4th, x cubed, x squared, x, a number, and a remainder. So I'll get negative x to the 4th minus 8x cubed minus 40x squared minus 198x minus 995. And now I'm going to do a minus 4,965 all over x minus 5. Okay, now we may not have time to finish the second example, but let's at least set it up because we haven't divided by a quadratic yet. So I would have x to the 4th minus 4x cubed minus 6x squared plus x plus 1, and I got all the terms, so I didn't need a 0 placeholder for anybody. And then I'm going to divide by x squared plus 2x plus 2. So what do you think about first if you're dividing by a quadratic now?
Simplify.
Just the first terms, right? Taken and saying. So we would look at the first term in the dividend, which is x to the fourth. The first term of the divisor. What's x to the fourth divided by x squared?
X is second.
X squared. So my first term is going to be in this third column for my x squared.
Oh, because it goes under where it was.
All the x squareds need to be in that same column, right? So it's very organized. That's how you know when you're done. And then what do I do with that x squared?
You times it by that.
Times it by
The divider.
the divisor. Yep. So x squared times x squared,
X to the fourth.
x to the fourth. X squared times 2x,
X to the third.
2x cubed. And x squared times 2, 2x squared. Okay, so now you got to distribute it to more terms, maybe? What do you do with all three of those red terms?
Change the
Subtract them, change their signs, right? They're all being subtracted. If they all came out positive, then they're all going to be minus. So we're going to have negative 6x cubed minus 8x squared, and we'll probably have to pull down an x. If you want to pull down the x plus 1, that's fine. Okay. So now you just restart, right? First terms are the only thing you can worry about. Negative 6x cubed divided by x squared. Negative 6x.
Would you do the second term too?
Multiply by everything. No. I won't mess around with the second term. Now I'm just going to distribute negative 6x to all those. So that's going to be what? Negative 6x cubed minus 12x squared minus 12x. So like that's where my second term starts coming into play, right? When I'm going to be subtracting all that stuff.
Yeah.
But I don't really think about it.
So you
It just
focus on the
happens.
first term.
You only worry about the first terms. What are you doing with all three of these blue terms?
Flipping them.
Changing their signs. You're subtracting them, which is adding the opposite. So they're all now going to become
Positive.
positive. So that gets me to 4x squared plus 13x, and then I've got a plus 1.
B.
So I got one more round to go. What am I going to multiply by?
4x squared.
We're just going to have a plus 4. So that'll give me 4x squared plus 8x plus 8. I'm subtracting all three of those things. So that's 5x minus 7. And that's my remainder. So then I would have a plus 5x minus 7 over x squared plus 2x plus 2. Follow the directions on your goal sheet for me for your homework tonight. Practice both methods, synthetic and long division.